Hello, I'm Paul Peterson. The idea of using robots to help the human race is not exactly new. Robots made the leap from science fiction to established science a long time ago. We've seen them disarming bombs at airports and exploring the surface of Mars. A recent Hollywood picture starred Will Smith with a supporting cast of thousands of robots. Robotics is even used in physical therapy, where devices strap on limbs and aid a patient's movement. Today we will look at a new field called socially assistive robotics, where a robot can be a companion and an encourager. Stay tuned for Aging in LA. At the University of Southern California Center for Robotics and Embedded Systems, robots are being developed that will play one-on-one supportive roles with the elderly, patients recovering from strokes and heart attacks, even children with social disorders such as autism or attention deficit disorder. Machines from the new field called socially assistive robotics operate not through physical contact or by performing some physical task, but through sheer social interaction. Let's meet our guest today. Maja Mataric is a professor of computer science and the founding director of the Center for Robotics and Embedded Systems at USC. Welcome, Maja. Thank you so much for joining us. You are the future. This is amazing stuff we're going to see today.
Thank you. We hope so.
Well, I want to ask a basic question. How did you get involved in socially assistive robotics? What kind of things did you see that a robot could perhaps fulfill that function?
Well, we originally got intrigued by trying to help people who have suffered stroke, because stroke is such a common disability these days.
Yes.
So over 750,000 people suffer stroke each year in the United States, and that will probably double in the next 20 years.
Wow, that's a little scary. But again, this is for the physical rehabilitation. People need encouragement to do it. Earlier I was hearing you say it's repetitive, it can be boring, but it's necessary.
That's exactly right. In fact, the main challenge in recovering from stroke is spending all those hours per day and doing productive exercise that's done just right and repeatedly over many hours. And that's something that people find, well, boring on the one hand and also challenging and difficult on the other.
Well, the name of our show is Aging in LA, Maja. So how can these robots assist our elderly population?
We're hoping to create machines that can fill a role that's right now unfilled for people who need to spend many hours a day exercising, being motivated to exercise in order to delay both cognitive and physical decay.
Well, that makes sense, but I wonder about the reaction of our seniors. Is there reason to think they will take to these robots, that they'll interact with them in a positive way?
Well, we think so because we've already tried this. We've put robots and senior citizens together, and in fact people with dementia and Alzheimer's, and they've been very well received.
See, I've never believed that stuff, that elderly people don't interact with machines.
You're right.
Good, you've already had a positive experience. We recently visited the robotics lab for the Center for Robotics and Embedded Systems at USC. Now, Maja, we're going to run some tape here, and can you describe what we're looking at, please?
This is one of our mobile robots. The blue coffee can thing is a laser that tells the robot how far other robots and people are. This is a hopping robot. This is a part of our lab. It looks just like you'd expect. There's some heavy-duty machines and some lighter machines. That's a helicopter for some of our other research. That's a boat robot for some other environmental research we do. This is actually an autonomous Segway robot that self-balances, so it doesn't need a person. Here's a hard-working graduate student, some work on the board, always lots of scribbling going on, and even a model of the human skeleton.
I see. Wow. This is going to involve a lot of different disciplines, human anatomy and motion work. How do you set a goal? Like we have a person who has a bad leg from a motorcycle injury and needs rehabilitation. Do you design the robot for that specific task, or will they be more generalized?
Well, we mostly focus on the brain of the robot, and that is its ability to think and to communicate with its user, the person whom it's trying to help. And so we don't necessarily build the robots, although we work with people who design them and build them, because you're exactly right. They need to both look the way they should in order to do the job, and also, particularly importantly, they need to behave in an engaging way.
Right, well, and behave. But are they voice activated? Do they respond to commands, or are they programmed to recognize physical movements, for example?
Well, the beauty of intelligent robotics today is that they're all those things. So they take inputs from all sorts of sensors, such as they have microphones so they can hear, they have cameras so they can see in a way. They can even have access to, for example, your heart rate, your blood pressure, the amount of sweating you're doing, how nervous you are. So a lot of different signals or inputs to help the robot to respond in a helpful way.
I see, and that really does personalize the robot to the patient. Now, how are these things built? Is this something that graduate students get together and say, here are the blueprints and this is a working model, or is this stuff sent out for fabrication?
Well, robots today are pretty sophisticated, so even though our grad students are very smart, they don't usually build them in the lab. We do design them together, and then we have them built custom for the particular use, or sometimes we can actually buy them off the shelf. So you can nowadays buy research robots off the shelf.
Oh, it is a brave new world, that is for sure. We have some other video that shows a little robot interacting with a stroke victim. And can you tell us about this? Because it seemed, I mean, look at this wonderful little guy coming up there.
So we're very interested in stroke because it happens so frequently today. Over 750,000 people have new strokes each year, and that number will double.
Right.
So in this case, what you see is a little robot that's not particularly pretty or fun looking, but it's really fun to interact with. So this robot has an ability to tell what the patient is doing. It can tell how far the patient is. It can tell if the patient is stacking books or magazines. That's a rehabilitation task.
Right.
And it can then encourage the patient.
How does he know which person is his patient? How does the robot know?
That's a very good question. So unless the robot has a way of maybe seeing and recognizing the face of the patient, which is hard to do when the robot is short and the patient is tall, if you see on the patient's leg there's a reflective band.
Right, there on the left leg, yes,
that's
you can
right.
see.
And so the robot actually detects that left leg and recognizes that particular patient uniquely from any other people that might be in the room or any other objects.
Is he giving verbal encouragement? Is the robot, he has a pleasant voice and is helping him?
The robot has a pleasant voice. It says pleasant things. Our robots never say unpleasant things.
Yeah.
So they're always encouraging, but they're differently encouraging based on how well the patient is performing. So sometimes patients need to be challenged a little bit, and sometimes they need to be sort of soothed and motivated.
Oh, because their movements get sloppy and it's not fulfilling the purpose of rehabilitation. Well, that makes sense. Now, of course, robots have infinite patience. They just don't mind doing the same thing over and over. So that's a wonderful idea, to be able to be encouraging, interact with a patient, and yet at the same time know when the exercise is not going as it should.
Exactly. Our goal is to create these machines that people will not want to turn off. So this will be some sort of a buddy coach nurse. And in that way, the person can enjoy playing with the robot and thereby do more exercises.
Well, you mentioned something earlier, because of there's a human cost for the therapist that this robot, it not so much replaces, but they can do the job for longer and with more patients in the course of a day. So that makes sense.
Exactly. It's very important to realize that robots are not aimed to replace people. They never could possibly replace people. What we're trying to do is provide care for people who need many, many, many hours of individualized one-on-one attention. And that just cannot be provided with existing care. So they fill.
That is really fascinating. And as you said, the numbers of our stroke victims are substantial. And yet the idea that they could be used also for a child with autism, who maybe would react in a more positive fashion to the robot than any human could possibly achieve.
Exactly. In another line of our work, we are working with children with autism spectrum disorders, which are also on the rise. Here's another disorder that's quadrupled in the last 20 years.
I've been hearing these numbers, 1 out of 150, and 25 years ago it was 1 out of 1,000.
That's exactly right. And no one really understands the causes yet, and people are working on that. But in the meantime, we have so many children with special needs. And here's a place where, again, intelligent, personalized technology could really help.
Well, and I'm thinking also people who are casualties in conflicts all around the world who may need help rehabilitating an arm or their vision may be gone. There's a big role for these robots to play.
That's exactly what we're hoping. In fact, going from stroke patients who are trying to rehabilitate their motor, their movement function,
Yes.
it's not a very far distance from there to traumatic brain injury patients,
Right.
such as veterans coming back from war.
Sure.
And so we're hoping that these technologies will really apply to all of these populations.
And that's a smart thing. I remember this woman who was the head of the Media Access Office, Gail Williamson, reminded me that a fall off a bicycle turns you into a stroke victim because the injuries that you sustain will mimic that same loss of function.
That's exactly right. In fact, a large number of people who suffer car accidents have very similar symptoms to veterans coming back from war.
Yes, yes, indeed. And boy, anything we can do to help them. Now, what about some of the robots that are actually in contact with you to help, perhaps when you have, real muscle damage or nerve damage, to sort of retrain the nerve pathways? Or will robots be involved in that?
Definitely. We have so far talked about what we call socially assisted robotics. So it's really the social interaction between the user, the patient, and the robot. But there's another field of robotics called rehabilitation robotics, which has historically been about having the robot help the person physically, such as hold their arm and get them to exercise. And what's neat is really a combination of both. Especially in the early phases, you might want the robot to physically move the person. But as the person recovers, the person really needs to work autonomously on their own in order to reach full recovery. And for that, it's the social interaction that's needed.
Well, and the notion of social interaction sort of tells me that the patient will be teaching the robot too. I mean, are they capable of learning? Are they able to modify their behavior?
They are.
Cool.
That's a major goal because, no matter how fun the robot is, it'll eventually get boring if you have
Yes.
to exercise with it for 6 hours a day. Anybody will get boring.
Yes.
And so the robot indeed has to learn. It has to adapt. It has to learn things like, how do your preferences change from hour to hour, from day to day? What happens when you get tired? Should it change its tack? Should it say something else? Should it read your books? Should it play you music? It can do all these things.
Right, and it could be used in a group setting as well, right? I mean, we might as well have a sort of a teacher, a physical therapist teacher standing in front of people.
Exactly, and in fact, we're very interested in doing that with patients with Alzheimer's and other forms of dementia, where they may be in a living setting such as a nursing home where they do exercise classes in groups, and they really need more of that to encourage them to talk to each other, perhaps to vocalize and to do physical exercise.
Well, I like that idea of taking the Alzheimer's patient as they are and yet using what facilities they have to interact with somebody. That would be really a remarkable achievement. But I guess I am stuck with stereotypes too. People are always saying that, well, seniors will never adapt to something like this. Yet you said your experience has been just the opposite.
It has. We've actually found that people are very open to these kinds of machines as long as the machines talk to them and are interactive and friendly. I think, in fact, people are much less comfortable with machines that they have to put onto their body. They feel more threatened. These machines are more like pets. We make them purposefully small, they're light, they're not dangerous, and they don't touch people. And so the idea is to establish that social interaction. It's like a buddy, but it's a pretty smart buddy.
Yeah, well, that's really great. But the learning capabilities, have we reached that stage where the robot can actually learn, for example, not just the tone of your voice, or you already mentioned about the biometrics, sensing your heart rate and all the rest. Will they be able to learn in different environments, and we're not always in the same place at the same time?
Oh, definitely. In fact, robotics research has already shown that the robots can learn sort of where they are, how to behave, how to improve their behavior. And then the new challenge is how to do that with a human user. Our work most recently showed that the robot can actually adjust its behavior based on the user's personality. And so that's very powerful because we find that the robot can adapt and say, oh, you tend to like it when I push you a little harder and challenge you in your exercise, versus sort of being very soothing and kind of letting you feel happy with what you're doing.
This is fascinating stuff, but it's time for a short break. When we come back, we will continue our discussion of kinder, gentler robots. We'll be right back.
A revolution has come to broadcast television, even bigger than the change to color. On February 17, 2009, television goes all digital. But without an upgrade, some TVs will stop working. Find out what you need to do. Call this number or visit dtvanswers.com to see how you can get free over-the-air digital TV with better picture, better sound, and more channels. See what you're missing. Make sure your TV is DTV.
Hey, buddy! Don't you know you should never leave a cooking pan unattended? And a working smoke detector can warn you of a fire. Like the one behind me. My hero!
Next time, listen to the ball. Have a smoke detector and a fire extinguisher that work.
How'd you know?
The ball called.
Welcome back to Aging in LA. Our topic today is kinder, gentler robots and how they will play one-on-one supportive roles with the elderly and others. Our guest is Maja Mataric, Professor of Computer Science and the founding director of the Center for Robotics and Embedded Systems at USC. Maja, I understand that these robots would find their first home in an institutional setting because of expense. But are we coming to that day when they will be readily available for people for in-home use?
Well, that's the hope. What we're hoping to do is demonstrate that these machines are really effective in a more controlled setting, such as an institution. The cost can really come down significantly. In fact, if you look at robots you can buy today, and you too can buy a robot today for about $200 and have it vacuum your floor, there's no reason why a robot couldn't help you exercise after stroke for not much more than that.
Well, that makes sense to me. I mean, we have all seen these remarkable machines go down and down and down in price as they sort of spread through the culture. But there are other roles that a robot could play. There may be a challenging set of stairs that an elderly person ordinarily wouldn't even tackle, and yet perhaps with assistance they can make it up those steps.
There is a big gap between robots that don't physically touch people and robots that provide physical assistance.
I see.
And the second category is more expensive and also potentially more difficult to make safe. Because if a robot is strong enough to help you, it also has weight, and it has motors, and it has batteries, and that becomes harder to make perfectly safe.
I see.
And so that will take a little bit longer.
Okay. Well, I'm going to be around. On our recent visit to the Center for Robotics and Embedded Systems, we were introduced to Bandit. Maja, can you explain what Bandit is doing in our tape here?
Well, here's Bandit. It's a friendly humanoid robot torso, and what it's doing is it's showing an exercise to a human user, and then the patient repeats the exercise. So really what's going on is it's a little turn-taking game in which Bandit does something, the person imitates, and the person does something, and here you see how Bandit sees the person. It's really the lines and squares.
Right.
And then Bandit imitates. And this is a way to motivate people to do exercise. It's really to make it a game. And you can make the exercise harder and harder with time, all the way up to, as we talked about, Tai Chi potentially.
Now, in terms of physical appearance, is it a good idea to have them so stark like they are there, or are you going to clothe them so that it's more cuddly?
We're definitely going to dress it up, but you know, it turns out in order to dress up a robot, you need very special clothes. You know.
Naturally.
So we're having those custom made.
I see. Well, then, a socially interactive robot should be a wonderful teacher, I can see, with acquiring language skills or perhaps teaching you to talk again after a stroke, because so many times loss of vocalization is part of that process.
We think there's a great deal of potential for exactly that. Even though you could use a computer to encourage someone to practice speaking, people are much more engaged to speak to someone or something that's like a companion.
It makes such perfect sense. I mean, these are engaging little creatures. I know you cautioned me about making it into some human thing. You call them its, right? I mean, even though they're
That's
given
right.
names.
They have names, and my students pick the names, and so there's a lot of spirit there.
Yes.
But we try not to assign gender because we don't want people to have certain unreasonable expectations from the robots. They are machines, and they're not replacing people.
Well, how does it work with the voice? I mean, some people would find a particular kind of voice very irritating and grating. Do you spend a lot of time on that as well?
We do study that problem because you're exactly right that some voices are grating. Different people perceive different voices and pitches and gender in the voice differently. So we found, for example, for our stroke rehabilitation robot, that everybody preferred a voice from a South African student in my lab, which had a gentle accent.
Isn't that something now? But I can see that happening, especially if there are repetitive commands. as we saw in that earlier video, the encouragement to continue to make that motion to pack a box could be tiring, to say the least.
Exactly. So the robot needs to keep it interesting. It needs to have emotion in its voice, encouragement, motivation.
Right.
But what it cannot do, or what it must not do, even though it could, is if, for example, it shouldn't switch from one voice to another. It should not speak as a male and then suddenly switch to female.
Right.
Because that breaks the engagement.
Right, that would be jarring. I understand. Now, you all saw Bandit, so let's watch it leading an exercise class of 1 or 50.
Please raise both of your arms straight up above your head, like this. Now please extend your arm to the side. Look at how I do it. And now please extend your left arm to the side, like this. And now please bend both elbows straight up. Here is how. You're doing a great job. Now please raise both of your arms straight up above your head, like we started with. Big stretch. You can lower your arms now. We are finished. Excellent job. You did really well.
That is great. Patience and encouraging, and yet the motions are so obvious that you want to mimic them. I found myself saying, don't put your arms in the air.
Well, we tried to make them simple at first. They could be much faster and much more complicated, but you have to start somewhere.
Yes, exactly. Well, speaking of starting somewhere, what is the process of introducing, say, a stroke victim or an elderly person to Bandit? Is it take a little while for, kind of getting to know each other?
We definitely do a warm-up session. So we basically bring the robot and the person together with a physical therapist so that they feel safe. And generally it's not been an issue. People will show different levels of curiosity, but they're not threatened by the machine.
Well, you have to be curious. Just think of the images in movies and television of helpful robotics, everything from an R2-D2, which had no human features, to C3PO. It's almost like we're built and ready to accept this kind of world.
Well, that's exactly what neuroscience shows. It actually shows that people instinctively, in a way that they cannot prevent, respond to machines that behave in a lifelike manner. So it's not so important what the machine looks like, but it behaves in a way that's lifelike, that's believable, then people respond.
And I noticed that you've spent quite a bit of time to have facial features that, while they are kind of stylized, they are definitely recognizable.
This is one of the areas that we're actually studying. We're trying to understand which part of facial expressions are most important in order to encourage someone to convey emotion. Things like, oh, you're doing great, versus, oh, let's do a little bit more. We can't make faces that are as similar as human faces with all of the expression.
Right.
And we don't want to pretend that. But the big scientific question is, how much is enough?
How far along do you think we can reasonably go, say, in the next 10 years? Will we be seeing even more of these in hospital settings, rehabilitation facilities?
I would bet on it, because right now we're doing already testing stage work. And I think within 10 years, we should be seeing some of those in the consumer market.
Wow. Well, crossing fingers. Now, you also have another robot, Sparky. Tell us a little about this fella.
Well, Sparky is a lot of fun. It's built by Disney Imagineering. And it's not as big as you think, but it has many wires to control all of its body parts. So it has, elbows and hips, and it's very cute.
Well, he's taking a little bow.
He is. And in fact, we're going to dress Sparky up. Disney will help us with that. And one of the things we'd like Sparky to do is to teach elder patients Tai Chi or some sort of exercise that could get them moving in sort of a flowing, gentle manner to increase their involvement.
Well, and there are so many joints. He has a lot of articulation here. That's a very sophisticated little critter.
He really is. We're happy to have him.
I guess so. Did you ever look back at some of the early designs or your early wishes, things you might have sketched, and think, how did well, how did I do that? How did I think that I could accomplish this?
Well, I have to say I'm extremely motivated by the users of these systems. And so if I ever am tempted to think, why am I doing this or will it work? When I talk to a stroke patient or a child with autism or anybody who is actually really thrilled to play with one of these machines and be helped, that's all I need to keep me going.
Well, that's satisfaction enough. I know in another field you see people who have used pets in assistive fashions, and they tell me the very same thing, that the reward is watching someone's life improve.
In fact, animal therapy has some similarities to technologically assisted therapy, and we'd like to study those and understand that as well.
Well, it's a wonderful idea, but I wouldn't mind them being cuddly and soft, you know.
It can, and there's no reason why the robots can't be cuddly and soft. Some people are actually developing teddy bear-like robots, and in Japan there's already been a seal puppet developed.
Oh, wonderful. It looks like our time is up for today's edition of Aging in LA. Thanks so much to Maja Mataric, Professor of Computer Science and the founding director of the Center for Robotics and Embedded Systems at USC. And now, it's time for our new feature on Aging in LA, Senior Stat Shots, where we look at statistics that pertain to senior citizens. Looking back just 50 years ago when robots were a dream and seniors who are turning 65 today were just getting their first driver's permit, what automobile companies do you think were the top 3 sellers in the United States? Well, Ford was number 1, General Motors number 2, and Chrysler number 3. Today, Toyota has pushed Ford out of first place to third, but General Motors is still in second. And Chrysler is no longer in the top 3. Now, as far as the U.S. share of the global market is concerned, back in 1958, U.S. manufactured automobiles and trucks accounted for 67.5% of world sales. Now that number stands at 17.7%. And back in the late 50s, foreign countries sold about 3.5% of the total U.S. car sales. Now they sell 45.1% of vehicles sold in the United States. And that's today's Senior Stat Shot. The Los Angeles Department of Aging produces this program with CityView, Channel 35, so that seniors living in Los Angeles and surrounding communities are well informed on the many issues that face them in everyday life. And also to let you know of the many services that the Department of Aging offers our senior citizens. Now, we'd like to hear from you with comments on the program, what you like, what you think can be improved, and ideas for future programs. Please give us a call. The number's there on your screen, area code 213-252-4088. That's 213-252-4088. Call us with your comments and ideas. We look forward to hearing from you. I'm Paul Peterson. For the Los Angeles Department of Aging, the people here at CityView Channel 35, and all of our guests on Aging in LA, thanks for watching. We'll see you next time.